Two and a Half Admins, episode 111. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, you've got a plug, Alan. The history of package management on FreeBSD.
Yep. This is another part of our kind of history of BSD series over at Clara. And we're talking about where the modern package management came from and how it's evolved over time.
Right, well, link in the show notes as usual. A few weeks ago, BorgBase published a report about SSD reliability. This is a follow-up to last year's report, where it looked like SSDs were more reliable than spinning hard disks. And now this 2022 report has confirmed that, and they look to be significantly more reliable.
The data's still somewhat limited. They only have about 2,500 drives in production versus the millions, I think they have of hard drives. But their failure rates have been pretty low. Although, again, as always, their annualized failure rate calculation numbers get a little wonky because it's like, well, we have one of these drive die, therefore 10.9% failure rate. It's like, not quite. But they explain their methodology and they're not trying to trick anybody there. So at least there's that. Interesting to see the models they're using and how many of them. Although some of them, it's like, we literally have 3. I'm like, that's an odd number. Literally. But the biggest thing to note here is that these are all the boot drives, so they're not taking quite the same workload as the regular hard drives they use for their vault storage, although they are replacing what were hard drives before, and so they do actually do like an apples-to-apples comparison on workload. And so it's interesting to see the results. They have some graphs, and then you can see that a little unclear where the line was going to go back in 2021, but now the line looks to be stabilizing around a 1% failure rate. Looking at how old the drives are, as they're only starting now to get some SSDs that are actually 5 years old. Although I expect over time that SSDs might run into more issues, just like hard drives do, once they get much beyond their design lifetime.
With the difference that the SSDs are generally going to be less likely to hit that wall as a factor of, operational time. They're going to hit that wall as a result of write endurance. When they exhaust their write endurance, that line is going to take off literally hyperbolically. It's just going to shoot through the roof. I do want to go back. Joe said that the failure rates for the SSDs are significantly lower than hard drives. While that is true, I do want to put that in perspective. We're talking about annualized failure rates from year 2 through year 4 on conventional hard drives of anywhere between 1.5 and 2%. And in the same time period, they're pretty much all right at 1% for the SSD. Now, on the one hand, yeah, you are talking about, it's a 100 to 200% improvement, right? The hard drives fail twice as fast, but in absolute terms, if you're only using a drive in a machine, there's not a lot to choose from between 1 and 2%. Now, where it does get more interesting, out at year 5, which is the last year we have data for on the SSDs, they're still flat at around 1%, and the hard drives at this point have climbed up to 3.5, and they're still going. By the time you hit year 8, you're at a 7% failure rate. And I suspect what we're going to see happen is, if you follow those curves out far enough, the hard drives, should you be dumb enough to keep them running longer than 8 years, you're again going to hit a point where it's pretty much just the failure rate is going to shoot off like a rocket. There's not going to be anything left. Now, for the SSDs, I would suspect they're going to stay flat for longer. So the difference between them and the hard drives is likely to increase with their age. But the other thing about that is, now we're right back again into what drives are we talking about? We're not talking about BorgBase's storage drives. We're talking about their boot drives, and their boot drives see very little activity.
They do have some logging, but yeah, beyond that, they're choosing SSDs that they don't expect to wear out within their useful lifetime. And so we don't necessarily are not going to see that big spike. But if we did compare SSDs to hard drives in a workload that had a lot more writes, we might, in fact, like Jim said, get to the point where when we hit that write endurance wall, it shoots straight up to almost 100%, whereas the hard drive can keep going at a 2% failure rate.
For BorgBase's workload especially, I suspect if the SSDs were over on the data side, they'd already hit that wall. You'd probably see it shoot vertical somewhere between year 3 and year 4.
Well, and, depending on the endurance of drives you buy and how much data you're writing, you can, I've seen people wear out an SSD in 6 months. But yeah, that's a choice you make when you buy the SSD. You buy one that has the right endurance.
The thing about that is when you talk about choosing the drive with the right endurance, I don't think enough people realize that is, there are several factors that contribute to the right endurance of a drive, but by far the most important one that most people run across is the capacity. A larger write endurance is why even if you've only got 20 gigs of data, you may still want to buy a 1 terabyte SSD. Because the write endurance of an SSD is measured in full drive writes per day. So the bigger that drive is, the more data you have to write before you're approaching that write endurance. Now, beyond that, there's a difference between SLC, MLC, TLC. You're basically having the write endurance every time you go up a level in terms of, single level charge to multi, which means 2-level charge to 3-level charge and so on. But most people don't really get a lot of say in that. You can avoid like a Samsung QVO that's QLC and will be even crappier. But within drives that are SLC or MLC or TLC, the only way you can increase the write endurance at the same capacity is for the capacity to actually be larger, but the drive just doesn't tell you about it. You have more spare media for the drive to swap in, and the wear leveling algorithm does its thing. So you might have a drive that says it's 1 terabyte. It's really got 1.2 terabytes of media, and it wear levels across all of it, so it lasts a little bit longer. But that's a small change. That's a 20% bump to the endurance. It's not like, oh, I bought Enterprise and therefore my thing lasts forever. It's not how it works.
Yeah, and the reason why a bigger drive gives you more is you're basically spreading that same amount of work over more cells, and there's also more over-provisioned space. The other interesting thing that this doesn't talk about is failure modes. With a hard drive, your most likely failure mode is just some blocks that suddenly you can't read, whereas SSDs, I've seen a lot more times where the device either goes completely read-only, which is not necessarily the worst failure mode, or sometimes where it just doesn't recognize that it's a drive anymore, or says it's a drive, but it's full of zeros, and every block you read is just zeros, and all your data is gone. And in those cases, that failure is maybe worse, but at the same time, I assume a drive is in a relatively binary state. Either it's working perfectly or I'm replacing it. I don't try to limp them along or anything. And so I don't know how big of a difference that makes. But hard drives, sometimes you have a bit more of a chance of recovering data than with an SSD, but you shouldn't be depending on that anyway.
I think that drive's going bad, boys.
Yeah. I guess on the previous episode, I mentioned using CW rsync to rescue some data off an external hard drive. It was one of those Western Digital MyBook things or whatever, and the head had got stiction to the media. And so I had to do percussive maintenance to get the head to move again and actually be able to read some of the data off of it. And it was not fun.
I like the freezer trick personally.
Yep.
You put it in a Ziploc bag in the freezer for like 4 hours and you get out and you got like maybe 10 minutes you can use it before it seizes up again.
Yep, I've definitely done that. And I've also done the video card in the oven.
Yeah.
To reflow it enough to get it to work a little bit more.
And in case anybody's curious, no, I do not believe putting an SSD in a freezer is ever going to bring it back from the dead should you have one that died. The big takeaway is that with SSDs, if you have a longevity-related failure, if you just reach the write endurance wall, that's one failure mode. And when you approach that mode, the whole SSD just gets ridiculously slow, typically read and write, but basically works. But the more common failure mode for SSDs is something else just completely dies and the whole thing is just off. Like there's no in between, there's no warning. Just one day your computer tells you, I don't have a C drive. And you're like, yes, you do. When it's like, no, I don't, and you replace it. That failure mode is a little less common in conventional hard drives, but it's not like it doesn't exist there either. I have heard some people argue that SSDs are dangerous because when the hard drive dies, you usually still have the option of sending it off to an outfit like Drive Savers to recover your data at a ridiculous amount of expense. In case you've ever wondered, they start at $800 a drive. That is the minimum charge. As long as I've scared you off with that, I will go ahead and mention also that they'll look at it and give you a price, which will be a minimum of $800. But they'll give you the price and you have the option of saying, oh, hell no, send it back to me, or okay, I'll pay. And, then they'll recover the data.
Yeah. I purposely, when I was doing the recovery on this, was like, I'm going to DD image this and work on it via iSCSI so that the customer still has the option of going to drive savers if I can't get enough off of this.
Yeah, and that's usually not an option with SSDs.
Because, data is not written out logically on an SSD, right? The flash translation layer is just scattering stuff everywhere, and it's got its metadata about where things are. And if that gets screwed up, that's when you get the situation of it doesn't work at all, or it reads the wrong data, or you just get back all zeros for everything.
Yeah.
And that's why it's really important to have a file system that can tell when that kind of thing is happening, like ZFS maybe.
There it is.
And you can make sure the SSDs are giving you back the right information and that you can detect when there's a problem.
This is why I love being on this podcast. It's the only place where I'm not the guy that was like, oh, he's going to bring up ZFS. I just know it.
Okay, this episode is sponsored by BorgBase, simple and secure offsite backups. Use promo code 25A to get 30% off your first year of backups. Manage all your Borg backup repositories in one place via web interface or API. Monitor usage, quotas, and security settings, and choose to be alerted about stale backups. Every repo is isolated, encrypted, and optionally append-only to protect against ransomware attacks. They even provide simple copy-paste commands to get started quickly. Plus, all users get expert support to help with backup strategy and setup. BorgBase actively supports the open source software that they've built their business around. They maintain the popular open source desktop client Vorta and sponsor many other projects in the ecosystem. So go to borgbase.com and get 30% off your first year as a new customer using promo code 25A. That's borgbase.com with the promo code 25A. I saw an interesting blog post by Pat Regan. How much RAM do you need in 2022?
All of it.
Well, he talks about how some of his RAM went bad and he eventually replaced it and he experimented with different amounts, 16 gigs, 24 gigs, that sort of thing. But he also made the point that he used to, when he upgraded his machine, double the amount of RAM. But then it got to about 32 gigabytes and he's just stayed at that for the last few upgrades. And so for his use case, he's pretty much found the limit of what he needs.
Well, more importantly, he dropped to 24 gigs as a result of that bad stick of RAM. And he was okay with it. He ran some benchmarks. He noticed that the single channel configuration meant that some synthetic benchmarks in particular ran significantly more slowly. I will tell you from personal experience, you shouldn't take too much out of that. Those synthetic benchmarks will expose the difference between single and dual channel setups a lot more quickly than like just normal use will. You're not just gonna be like, oh, my computer's a dog if, it slips down to single channel mode.
Yeah, the RAM is one of the fastest components in your computer. If it's the bottleneck, you're in good shape. More
importantly, if it's the bottleneck, you're in a pretty unusual workload. And also, you're in pretty good shape. But the real point was that whereas in earlier days, the absence of that extra 8 gigs of read cache would have made itself immediately felt when, the C drive was a hard drive and not a fast solid state drive. Now the need for a read cache isn't as strong. It's still, to be clear, it is a nice thing to have. Even incredibly fast solid state drives, really, really fast NVMe drives are nowhere near as fast as RAM. But the point is, they're fast enough that for most use cases, you may not notice or mind the difference. If the rest of your storage workload isn't too high, just not running uncached and having to read everything every time may be sufficient. Whereas back in the old days with like a spinning Rust hard drive as your C drive, it basically meant that the first time you opened anything, you hated your computer. You absolutely hated it. And then like the second time might be okay, assuming you had enough memory cache. Now it's like, well, just loading things directly from the metal is not so bad. However, he touched on also the idea that, well, maybe you don't need swap anymore either. Or, maybe more swap is fine. Maybe actually swapping is fine. And that is not the case. He minimized the impact of it, but he also noted that when he tried artificially exhausting his RAM to make his swap usage increase, he was like, for the most part, it was fine. But then, I don't know, sometimes the whole computer, would just kind of freeze up for a second or two. And it's like, yeah, well, those were the times you actually needed things back out of swap. I will tell you, having very specifically tested for has swap become usable now? both with the original introduction of SATA solid-state drives, I was very excited with the idea that maybe swap will be usable now. Maybe getting into your swap no longer means an inescapable death spiral for your machine. And I very quickly discovered that no, it does not mean that. It's still not anywhere near close enough to RAM. And if you dip into it heavily, it's a death swap. It's still true now, even with really fast NVMe drives. You do not want to have to use swap. So the takeaway here is that it has become a lot more okay for most people to only have enough RAM to fit your programs and their immediately necessary data, like textures in a video game or whatever. Like only having enough RAM for that is more fine than it used to be. But you do still need that much RAM. You do not want to go into swap. You will still want to throw your computer through the window if you do.
Yeah, it goes back to the old adage that free RAM is wasted RAM, and that's why your kernel's going to use that for buffer cache and keep some content from disk and memory because it'll be faster. Nowadays, if your storage is fast enough, you don't need to rely on that cache so much, and you can use that amount of memory for other things. The first thing I noticed from his stats here is he's only using 9 gigs of his RAM, which I'm guessing means he doesn't have a browser open.
Yeah.
The biggest reason that my machine has 32 gigs of RAM is because I have like 47 tabs open at the moment, and that's my life now. Plus having to run the Slack client and then an email client and a file editor and all this other stuff. It very quickly means that at least half my RAM is used by applications at all times. And then I have some slack to be able to run a VM or two, which was the big reason for me. But yeah, I think it is a good point that now the latency you see on things like NVMe is, I think, where the big difference comes through. It's not the throughput. Like, your hard drive, you can read 100 or 200 megabytes a second off of it. But that's if you're reading one big, nice sequential string. Whereas NVMEs now are getting to the point where you're talking about single-digit microsecond response times versus 4,000 microseconds for a hard drive as the average, not even the high end of it. He's like, you're probably typically going to see more like 20,000 microseconds for a hard drive versus 4 or something like that for an NVMe. And that makes, as it turns out, a huge difference in how long it takes to get a little bit of information that's blocking your application from doing the next thing off of that disk. Your RAM is still going to be faster, but you really don't have to lean on it nearly as heavily as you used to. But also, no, I don't ever want a machine with less than 32 gigs of RAM again.
No, definitely not. I have 64 gigs in my machine, and I am not at all upset about having 64 gigs. But to be fair, Alan and I do a lot of stuff that a lot of, I don't want to say normal people.
Right. My laptop is fine with not having 64 gigs of RAM.
Yeah.
Because I'm only going to run one VM at a time on it. But like when I'm doing experimenting or working on stuff for training courses, I'll have somewhere between 1 and 6 VMs running at a time. Mm-hmm. And I'd like them to have enough RAM to be able to do that.
Yeah, same here. I could easily have 8 VMs running and 80 plus browser tabs and be doing other stuff. And I want it to all work and work well. And if I want all that, then I need a ton of RAM.
I also threw a link in the show notes for an article we did a while back about swap and sizing it, and why you probably still want some swap. You don't necessarily need a lot, but why there is still some advantage of having a bit.
Okay, this episode is sponsored by Kolide. The challenge with endpoint security has always been that it's difficult to scale, and when remote work took over, the challenge got exponentially harder. You need visibility into your fleet of devices in order to meet security goals and reduce service desk tickets. But how do you get that visibility when different parts of your company run on Mac, Windows, and Linux? You get Kolide. Kolide is an endpoint security solution that gives IT teams a single dashboard for all devices regardless of their operating system. Kolide gives you real-time access to your fleet's data and can do things that traditional MDMs can't. And instead of installing intrusive agents or locking down devices, Kolide takes a user-focused approach that communicates security recommendations to your employees directly on Slack. You can answer every question you have about your fleet without intruding on your workforce. Visit kolide.com/25A to find out how. If you follow that link, they'll hook you up with a goodie bag just for activating a free trial. That's kolide.com/25A. Let's do some feedback then. Mars says, I just listened to episode 108 and was astonished upon hearing about Cloudflare. I use them and have been happy with their free tier service, but now would love to move away from them. What alternatives would you recommend?
It depends what you're using them for. If you just want a CDN, I think Fastly is currently my go-to. I don't know if they have a free tier, though. For DDoS mitigation, there's a couple of other services, although I don't really have one to recommend off the top of my head.
That's kind of the problem, right? That a lot of what Cloudflare does, no one else is doing, especially with a free tier.
Right. Well, it turns out defeating denial of service attacks costs money, and Cloudflare has startup money.
Yeah.
It looks like Gcore has a free tier. Included in the free plan, Gcore offers 140 or more points of presence, 1,000 gigabytes of free traffic every month, anycast balancing, DDoS protection, and a knowledge base. Yeah, gotta make sure you let everybody know you get the knowledge base for free, I guess.
Yeah, I guess it also depends what you're using Cloudflare for, right? If it's just CDN, then you might ask, do you need a CDN for what you're doing here? And there's also plenty of other options there, including the one Jim just mentioned, or Amazon, or other CDNs. And then if it's more about the DDoS protection, it's a bit sad that we're getting to the point where only some of the largest providers on the internet can actually offer this kind of DDoS protection because of the scale of the attacks we've started to see.
Could it be argued that the reason we've seen the scale of the attacks that we have is because Cloudflare exists and people have needed to win that arms race?
Not necessarily. Like, I'm just thinking back to some of the big ones that happened against like OVH, mostly related to like Minecraft servers and stuff that kids get into. Usually the source of most of the biggest ones was, you know, we saw like the UDP reflection attacks that turned out you could turn the IPMI on every server in the internet into an NTP reflector, or the ones that affected some DNS servers. And the most recent one that we talked about here even, I think, was the one model of security camera DVR that was sold under like 50 different brand names and had the same vulnerability in all the versions of it, and things like that. And, you know, I know with protocols like Quick, we're starting to see some resistance to that kind of amplification attack. Like, the protocol's actually designed so that the request always has to be as big as the response or whatever to make sure that somebody can't turn it into an amplification attack. And so maybe we'll someday get to a place where it's less of an issue.
It's a little off topic, but I have to scream again about how many people are just exposing IPMI to the bare ass unfiltered internet. Like, what the hell are you doing? Amplification attack or no amplification attack, don't expose remote control to the entire internet. All right, I'm done.
The internet's done a good job of cleaning those up by complaining a lot about them as they were the source of all these denial service attacks. And most of that's been cleaned up now, but it was never a good idea. So yeah, recommendations. I don't have much experience with those. I built my own CDN last time I needed one, but that was years ago. And it only does video now.
Tells you all you need to know right there.
Yeah.
In addition to Gcore, which to be clear, I have not personally used. It does seem to have a pretty good reputation. Website looks good. They're saying the right stuff. Give them a shot and let us know how it goes. In addition to that, like if this is specifically for a WordPress site, for example, there are some plugins that have built-in free up to a certain point in terms of traffic CDN support. I want to say Jetpack has one. So if that's specifically what you want is for a WordPress website, you might want to start out looking within that plugin ecosystem and looking at recommendations for that. But if it's for something more generic, I'd have to say, again, if free is a requirement, it looks to me like Gcore is probably your best bet.
Okay, Mark says, I love it when you touch on networking topics. One thing I'll say is that it's your duty as internet citizens to talk about good traceroute etiquette, or else you'll find yourself creating admins with enough info to be dangerous to networking professionals everywhere. I recommend your whole audience reviews the following PDF, and this is a practical guide to correctly troubleshooting with traceroute. Also, Alan brought up the point of multipath networks. That brings up the interesting topic of the Paris traceroute. As traditional traceroutes do not properly capture a map of the topology, and the various diverse probes sent often confuse the operator rather than help. And then he links to Paris traceroute. A useful tool for admins to add to their toolbox when MTR and traceroute aren't cutting it or are producing more questions than answers. The findings of the research were even minted in RFC 9198, although I'll admit it should be a last resort as it's far more cumbersome to use and distribute than MTR. Finally, for those that really want to test their networks, they might want to consider getting creative with a traffic generator. Thanks to things like DPDK and Libra routing daemons, gone are the days when you have to buy a 500k IXIA shelf to push those packets and measure results. A decent implementation, surprisingly, comes from Cisco, and then he links to T-Rex.
Yeah, quick note on that. Amazon does not like it when you run T-Rex in AWS, even against your own instances.
I would just like to point out that the same guy that was like, hey, don't unleash people out there running trace routes because that'll create a problem for network admins, then goes on to suggest a traffic generator.
True.
There's a bit of a conflict there.
Although the traffic generators usually are meant for local network.
Yeah, there you go. Are meant to be run locally. Meant to be.
Right, but they generally require like MAC addresses and so on. But yes, you could still, it wouldn't be the most efficient tool, but you could definitely wreak havoc with it.
Okay, this episode is sponsored by Linode. Go to linode.com/25A, support the show, and get $100 free credit. From their award-winning support, offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. And check out their managed MySQL, Postgres, and MongoDB databases that allow you to quickly deploy a new database and defer management tasks like configuration, managing high availability, disaster recovery, backups, and data replication. Simple and fast to deploy with secure access, their flexible plans include daily backups. So go to linode.com/25A, create a free account, and you get $100 in credit and support the show. That's linode.com/25A. Let's do some free consulting then, but first just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And if you want to send any questions for Jim and Alan or your feedback, you can email show@2.5admins.com. Okay, Matt says, how strong should my user/sudo passwords be, and should they be different on every system? For context, I'm using SSH keys and have disabled password login as well as root login. I mostly use Ubuntu, but I've been testing some FreeBSD systems recently. Not sure if that makes a difference to the answer.
It doesn't really make a difference to the answer. First question really is, are you using some kind of two-factor? Because if not, you probably want to be, especially if you're looking at making your user or sudo password less strong. The other thing is also, how are you doing your SSH key? Is it a normal SSH key with a local password? Is it an unencrypted SSH key, or is it an SSH key on something like a FIDO or YubiKey token? Because all of these matter a bit, and it comes down to how many factors and how much trouble is it, and how do you mitigate that? You know, with sudo, making it not prompt you for the password too frequently can be more helpful than having a weaker password that you use a lot, or even choosing to do passwordless sudo, as long as you make sure that to get into the user that's going to do the passwordless sudo, that you've set up Duo or Google Authenticator or something integrated with the SSH. So in addition to your SSH key, you have to provide some other two-factor authentication.
So moving back to the actual question about passwords and how strong they ought to be, I'm going to give you the same advice that I give everybody who doesn't run away fast enough when somebody says the word password. I strongly recommend Diceware-style passphrases. That's an easy Google. The concept is that you choose a certain number of just plain old dictionary words, no special tricks about them. And with sufficient words, you have sufficient entropy to defeat brute force or even well-informed dictionary attacks that understand exactly how you came up with your passphrase, but don't know what it is. For something that's going to be exposed directly to the internet and you are genuinely concerned that an advanced threat might find it and hammer on it, you should probably be looking at minimum 5 words. If you're not quite as concerned about APTs, 4 is probably still enough entropy. If it's something that's not exposed to the internet and you're not really that worried about it, but you would definitely, like your little brother, not to figure out an easy way to hammer through it, 3 might be sufficient. But the big thing about this is you need about 4 words to approach the entropy of, I think it's like an 8 or a 10 completely randomly generated string of characters, complete with all the ugly symbols and everything that you will never be able to remember and honestly even have trouble typing. 4 perfectly normal words is about the same amount of entropy. So you can remember 4 normal words. You can type 4 normal words. There's an XKCD that made this stuff, relatively popular.
Yes.
Correct horse battery staple. So if your random generator comes up with those 4 words, don't use that.
And also be highly suspicious of your random word generator.
Yeah, correct horse battery staple is the Hunter 2 of Diceware passphrases. But anyway, so my point is, basically anytime you have to use a password for anything, I really recommend this is how you think about it. Don't do one weird, funny word that you came up with, or, it's your dog's name, but it's okay because you added your daughter's birthday to the end, or, whatever. Not only is that a lot easier to guess than most people think it is, but you're probably going to repeat that in, different patterns. You leak one version of it one place, it's way easier to derive the second one than you think. Attackers are more likely to try to derive it than you think. Because you might think, well, nobody's going to bother with that with me. And, well, if it was like this one dude hunched over his keyboard, like trying to get into your specific whatever, maybe not. But that's not how it works. They're going to feed it to a tool, and the tool is automatically, algorithmically going to try likely variations of things. So you get your password dumped one place, it screws you everywhere. So don't reuse passwords. Do the Diceware style thing. If you want to vary the length, according to like how secure you need that individual thing to be, fine. But just don't reuse them. You'll be amazed how many of those will stick in your head if it's something that you use fairly frequently. And for the ones you don't use all that often, you put that in a password vault like KeePass. And so, you look up something that you haven't had to use in like 3 or 4 months and you forgot it in your KeePass, the stuff you do every day, or even the stuff you do every week, you don't have to look back at it. It will stick in your head. I promise. It's amazing.
Yeah. And also to Jim's point, typing a 4 or 5 word password is a lot faster than something that's just a jumbled bunch of different characters where you're like, did I capitalize the Y in the middle of that correctly? Or what's the right key combination to type that weird symbol?
Right. Well, we better get out of here then. Remember, show@2.5admins.com if you want to send in your questions for Jim and Alan. You can find me on Twitter @JoelRessington.
You can find me at JRSSNet.
And I'm at Alan Jude.
We'll see you next week.